and welcome to the fifth in our series of virtual trade shows brought to you by the Automation Village. My name is Chris Little.
And I'm Dave Spencer, and in this show, or this trade show, we basically bring you content from the automation and SCADA industry and try to fill that void that has been left with the lack of trade shows recently, where we try to bring you new ideas, new concepts, and also show you some of the ways that some people are solving things, oftentimes using a little bit out-of-the-box solutions. So we've got about an hour's worth of content for you today, where we're in our summer format. It's a little bit shorter than what we had been doing previously, but we've got a great show with really interesting content. It's going to be about 50% new content, and 50% will be from our previously sort of most engaging content that we had received from our audience.
Greatest hits, basically. So first up, we're going to have Mach Alert, which is going to tell us about the really innovative fire station alerting system.
Right, and then after that, MPE is going to tell us a little bit about a project that they did with the city of North Vancouver, upgrading their telemetry and SCADA system.
And Custom Control Systems is going to talk about how they use drones to safely measure signal strength in remote telemetry environments.
Right, and then after that, we're going to have Xylem tell us a little bit about using autonomous vehicles to optimize site selection for all kinds of different sensors and other things.
So, and in there, we're going to give away 2 prizes.
That's right, and each of these is going to be a $100 gift card to the favorite online shopping voucher of our selection.
That rhymes with Zamadan.
Yes, it does. So if you want to win those, then queue up your email, because the way this works basically is that we give you an email address and we give you a subject line, and if you get those exact, send us an email, then you have a chance to win. Unless
you are one of us, or our friends and family, or you are one of our presenters and one of their friends and family. Other than that, you're wide open. The rules are written more in full at the bottom of the screen and also in the description for our live stream.
Right, so with that out of the way, let's start getting into our first presenter. So Chris, you did this interview.
I did. It was really great. Ernie Ramos, who is the general manager of Mach Alert, he was telling me about this innovative system. And what's interesting is that they have a long history developing SCADA systems in a variety of markets. And they were able to bring a lot of the standards of SCADA, including mission critical, reliability of data transfer, and bringing that to an industry that doesn't normally use a SCADA paradigm, which is the fire station alarming system, and how they put that in place across North America, including a massive system in the city of San Francisco, which is why it's part of our West Coast road trip.
Right, and if you didn't get that, you saw the intro. Typically, we come to you live or virtually live from a certain location, and to carry on the theme of the road show, we're doing it on the West Coast in California today. So you'll see a generally themed presentations that all fit that kind of place.
So before we jump to Ernie, this is part of a larger interview that's well worth watching. And if you'd like to see the full thing, simply go down again into the description for the live stream and you can click to that.
Yeah, so I wanted to share with you a little bit more about what we do today with fire station alerting. And I'll speak a little bit about the parallels of SCADA and fire station alerting and how the Mach Alert team kind of leveraged that experience. Mach Alert actually has the skills and the experience to work on the Motorola radio network. And as you know, in the SCADA industry, getting communication from the field all the way back to one dispatch point, accumulating that data and sending it back is basically the principle of SCADA. Well, we utilized that and said, here we have the Motorola radio network, where your primary dispatch there, that would be instead of your typical SCADA dispatch or control room, it's our 911 center. That is the actual point where if you dial 911, that is the dispatcher that actually receives the call. In the same dispatch area, we put a Mach Alert server and what we call the alerting interface controller. And that is an RTU in the SCADA world. And then below that, you see what we call a computer-aided dispatch. That's a software package that the 911 system operators use in order to put in all the pertinent details once you dial 911. For example, they run that software and dial in structure fire, address, TAC channel 6, rescue 7, engine 5, all those pertinent details. So in that, going back to the alerting interface controller, that is a piece of hardware that actually communicates over the radio network and as well redundantly over the IP network. That is crucial in the fire market to have levels of redundancy. Talking about redundancy, you can have a geo-redundant 911 center as well, and you can have the same exact hardware there in case there's a situation where the primary dispatch has to be evacuated. You have a secondary. And then, of course, you have your fire station. In the fire station, the Mach Alert team puts in a control panel the same ACE3600 RTU remote terminal unit. We also put in there a voice radio and a data radio. A data radio is the wireless communication that communicates over the radio data network. And the voice radio is actually where the dispatcher, when they key their voice, it's actually heard at the fire station. So you have your fire call, call 911. Fire, what's your emergency? Dispatcher starts to type in all the address, details, and so on. Once they get the recommendations from CAD, computer-aided dispatch, it goes right to the Mach Alert server, and as soon as they hit send, it goes over the IP network. At the same time, we send that over the radio network. And this is where Mach Alert's a little different. We redundantly send it at the same time. We don't wait for one primary means of communication to fail before we flip over to the secondary. Every second counts in a fire situation. So once it gets to the fire station, whichever one gets there first gets processed. So off goes the fire station receives the alert and has a heart saver ramped up tone. We ramp it up and then we follow that by what we call text to speech. And text to speech is actually all the pertinent details that the dispatcher typed in at the dispatch console. The address, engine, cross streets, TAC channel, all of that gets converted to speech and broadcast out over the fire station's PA system. So the dispatcher, in this case, does not have to key their mic and actually speak over the PA system. At the same time, we wake up all their TV screens and monitors all across the fire stations and display that same incident details. So what we call an incident display board. And then we have the ability to send that also to their thermal printers and print that out as well. All of that gets the information to the firefighters as soon as possible in many different forms. And then with the, of course, expanding on our automation from what we've learned from SCADA, where we have the ability to open the fire station doors. And in this case, the fire station this call happens to be fire. So we're gonna go ahead and open those doors. And out comes the fire call, out comes the rescue vehicle as well. So that is basically how a 911 call starts and goes through the radio network as well as the IP network all the way to the fire station and sets off what we call all the bells and whistles at that end. And that took me about 10, 15 seconds to say, but once the dispatcher gets the information that it send, that information goes over to the fire station in less than a second on the IP network. So it's very quick and very efficient. And here we have a screen that sits right in front of the dispatcher. They can choose an emergency, in this case EMS. They choose the fire station. They have the option of doing a text-to-speech there. Then they choose their send button. You have 57 seconds now to speak if you choose to, or just let the text-to-speech do their thing. So once they hit the send, it goes out to the fire station.
Building fire, residential, operations on TAC 2, ladder 7, Quint 5, 1734 US, 27010.
We wake up their TV screens. Here you're looking at an HD monitor that has a fire call. It'll actually speak all the pertinent details in this text-to-speech there, as we call it. We'll use Google Maps, and with that number 23, that's their turnout timer. And once the incident details are done, they can flip over and give them pertinent details. And in these days, people are displaying COVID-19 updates. Again, it can speak multiple languages, so you can hear it speak English, and then it can repeat it again in French. We also can light up their fire station. So in this case, the fire station was a medical call, so we chose blue. In this case, we're lighting up the bunk room in a blue light, and we also use that egress lighting out to the apparatus bay. And we could do that with what we call zoning wall switch. So that blue bunk there in the fire station, if the medic actually switches out and the next following night, a fire guy or an engine guy sleeps there, they can choose the engine button. And we would only wake up, send alerts to that particular bunk room, and only wake up that speaker if there's an engine call. We have a Mach Alert mobile app. So in case the firefighters are not in quarters, as they say, and they're out in the field, the dispatcher there can actually reach them over their smartphone and Android tablets. Here's a sample of what it looks like once the mobile app actually wakes up. You can see it's an EMS alert. We put a countdown timer, and there's that map incident button, the red bar with the turn-by-turn directions. We have implemented this in San Francisco, and San Francisco came back to us years later and said, well, we like your package. We enjoy using it, but we want to hit the firefighters outside of quarters. Do you have something that we can reach them on their portable radios or their smartphones? So we're in the process of actually sending them what we call text-to-speech over the air. It goes over the radio consoles and actually hits their portable radios for their particular apparatus. We also sent them the mobile app as well. Here's a little geographical map showing where we deployed Mach Alert. You can see San Francisco here on the West Coast. You can see Toronto with over 90 fire stations utilizing Mach Alert. And you can see our home base here in Florida. We have quite a bit of dots there in Florida near our Tampa facilities. We also have 158 deployments out in Toronto and the Ontario region as well. So Mach Alert is continuing to grow, and we enjoy using our SCADA industry experience in the fire station alerting market.
Thanks, Ernie. Dave, what really struck me at the end of that presentation was the map that he put up of all the installations. We always kind of talked about the big installs in the city of San Francisco and also the city of Toronto, but he really covers that map, doesn't he?
Yeah, I thought the same thing. I was really surprised when I watched that interview. You think about a SCADA install in each of these places, and you oftentimes forget that, when you look at these many sites, each one of these sites isn't necessarily just like a well or a lift station or something. Each one of these things is actually a fire station. So there's a lot going on at each site. And yeah, they did a really incredible job, even going down to the detail of having the lights that change color based on certain things is pretty amazing, actually. I thought it was a really good thing. And it was the first time that I really heard the details about the system. I kind of heard that it had existed, but I never really knew much about it. So that was really interesting.
Speaking of details, if you want to watch the full interview, you can do that by simply clicking the link below in the description.
Right, cool. So next up, we have our first prize draw, right? So in order to enter the prize draw, you're going to look at your screen now. You should see to send an email to natasha.lutz@trihedral.com, and in the subject line, exactly how you see it, you're going to want to write powerful SCADA software. So send that out to us, and if you qualify for the contest, then you will have the chance to win a $100 gift card to a certain store, which rhymes with Zamadan. Next up, we're going to have Zane Spencer from MPE in Alberta tell us about a project that he did in BC for the city of North Vancouver. Now, this is a project where they were replacing their telemetry system and doing a SCADA upgrade. And Zane's going to tell us about some of the challenges with that project, and also sort of the mentality of working through that project to meet the customer's needs and get everything that they needed. So let's bring it over to Zane to tell us about that.
Sounds good.
Zane, how are you doing today?
I'm good, Dave. How are you?
I'm doing very well. So Zane, to start off, why don't you tell us a little bit about the District of North Vancouver?
You bet. So District North Vancouver is a municipality that is located on the north shore of Burrard Inlet. So they're part of the Metro Vancouver region. They're a separate entity from the city of Vancouver, and they have about 85,000 residents that they service. Now, like many municipalities in Metro Vancouver, they are responsible for providing potable water to their residents through a series of pump stations and reservoirs, and collecting sewage through a series of lift stations. But they don't have actually any treatment facilities of their own.
So tell us a little bit about how you guys got involved and what the district was really looking for, and why they were reaching out to do some upgrades with their system.
So our first involvement with the district came many years ago when they went out looking for somebody to upgrade a legacy SCADA system. And back at that time, they weren't looking to make any changes. They just needed to go to the latest software version. But they realized there was still a lot of work that they had to do to get them to the modern age. And back when we first got involved with them, that wasn't feasible. But they worked and planned and kind of set the stage for the modernization, which led to this migration project where they moved to VTScada.
Right, and this modernization was a lot more than just the SCADA system. It was the full telemetry and everything, was it?
It was. So the scope of the project involved not only upgrading the SCADA software, but also implementing a new front-end unit or front-end processor. They used Motorola RTUs at the district. And so they had a legacy MCP-M front-end processor, and that was upgraded to a modern IP gateway model, which actually factored heavily into the software selection process because VTScada can natively support interfacing with the IP gateway hardware. Part of the reason they held off for so long in doing that is the change of that front-end processor necessitated a rebuild of the SCADA system from the ground up. Right. So it was a much bigger project than just modernizing software. And so they took their time and they put a couple of years of their effort into planning this out and making sure they had all their bases covered. So when they went into this modernization, it could be done seamlessly.
Right. Okay. I got it. When it came time to actually make their selections, they went through a bit of a process for this, and I guess you guys worked with them on that. Can you tell us a little bit about the selection process and how they ended up with VTScada?
Yeah, so the district, like many public entities as a municipality, they had to go out to market and see what was available. They couldn't sole source or pre-select software. And so they developed an RFP that very clearly defined what their system was, what the objectives that they were looking to meet were, and they put that out to market to see what the responses were. They certainly had a few responses from integrators that were looking to use VTScada. And so when they were going through their evaluation, one of the comments they had was they determined pretty quickly in their evaluation that VTScada would be the software package that they would go with based on the number of integrators that had selected it and the functionality that it provided out of the box. And then fortunately for us, we came out on top of the integrators that had chosen VTScada, and we were selected to complete the modernization for them.
Right. Yeah, and I've seen a bunch of images from the screen that you guys have put together for that application. And it looks like you guys took the direction of going a little bit toward kind of a high-performance interface. Can you tell us a little bit about the application development process, some of the things that you guys did in terms of making it as efficient for the user as possible, but also some of the things that maybe went very easily and other things that you guys had to work a little bit, but came up with some sort of unique solutions to?
Yeah, so we included a fairly lengthy preliminary design phase in this project. And so we worked very closely with the district, with their technical staff and their operations staff to define the look and the feel of the SCADA screens. And we always strive to move towards industry standards, move towards high performance graphics. Of course, there's always a little bit of pushback and resistance from operations. And so we did have to make some concessions. For example, we included a green dot in the middle of pumps that indicates run status rather than the completely shades of gray look and feel. But once we kind of hammered out with the district how they wanted the screens to look, we were able to come up with a very templated look for both sewage pump stations and water pumping stations. where certain aspects of the screen were dedicated to certain functions of those stations. And then we were able to move into some of the customizations. So things like the alarm roster. And so we were able to work with the built-in functionality of VTScada and customize it to meet their specific needs, which included having 2 dedicated sets of operators, one for one portion of the district, another for a different portion of a district, and then having variable call-out delays based on alarm priorities, criticalities, and other factors. So it ended up being quite an undertaking, but we were able to do it using all of the VTScada built-in tools and then building some nice configuration pages for them so they didn't actually need to go into the roster properties to make adjustments to those.
So Zane, to meet the full requirements of this project, you guys worked with Trihedral's engineering team a little bit to develop some of the more advanced features that the district was looking for when it came to the Motorola RTUs. Can you tell us a little bit about that?
Yeah, you bet. So one of the firm requirements that the district had in their RFP was the ability to interface with redundant Motorola IP gateway configuration. And so they wanted a driver that was able to interface with this redundant configuration and issue the appropriate commands for redundancy switchover. And we worked with Trihedral Engineering during the bid process, and they made a commitment to us and to others that were bidding with the VTScada product that they would add this functionality to their existing Motorola IP gateway driver, and that the new functionality would be available in time for commissioning of this project.
Right, thanks. And while you guys were developing, the customer also wanted to retain all of their existing data. Is that correct? Can you tell us a little bit about that?
Yes, it is correct. And luckily, VTScada had just rolled out this functionality. And so we worked with the Trihedral team a little bit, but really the functionality of that aspect was so simple that we were able to quickly automate the process to extract data from their existing historian and backfill it into the new VTScada application. So we were able to save about 10 years worth of their historical data from all of their stations. And it was the vast majority of their important historical data. So analog values and key discrete values were all backfilled.
All right. Well, thank you very much. I really appreciate you putting the time together. And for anybody who's looking to read a version of this interview today, then we've got that condensed and we'll link that down below so you guys can go there, check that out at the end of the Automation Village. So have a great day, everybody. I will see you back in the studio. Thanks very much, Zane. Appreciate it.
Hey, thank you.
All right. All right, thanks for that, Zane. So one of the interesting things about that, and something that a lot of people don't know about Trihedral and VTScada, is that if you do need some custom development, you can always reach out to us. We do have an engineering group that does that kind of work. So in this case, we agreed to make that Motorola redundancy of the RTU system compatible with VTScada. So if you have a similar need, or if you're even interested in that specifically, then please reach out to us and we can help you out with those items.
So coming up next, I am now seated because I'm about to do a presentation on the VTScada Application Manager, which is the first thing anybody sees of VTScada.
So let's get into it.
All right, so I'm going to share my screen. So this is the VTScada Application Manager. This is the first thing you see when you install VTScada, and it's the first thing you see when you start it each time. The Application Manager basically lists all of the applications that you can start. That means your production applications, ones that are in progress, or your debugging tools, as you see here. So in this menu, you would start them, stop them, open up their properties, and so on. And because I work in marketing, I've got a ton of different applications that I can start at any given time. So as you can see, with this very, very long list, it can be a little bit confusing. So in version 12, what we did is we added the ability to create another list. So I've got a few of them here. So I can click back and forth. And these are applications that I use for showing off our master and subordinate applications. I can click backwards and look at diagnostic apps. For power systems, water, wastewater systems. So it's a nice way to kind of sort the list And also a nice little feature here, you can drag it so you can actually open up all of your different lists at the same time. So from this interface, you can also add a new application, which is a very simple thing. You just type in a new name, hit next, and you'll have a brand new application with all of your standard VTScada features in it. From here, you can also set up your internet clients. So if you've licensed thin client connections, this is where you'd set that up. This part of the process literally takes about 30 seconds to set up, and then you just have to set up your SSL or TLS, as we say, your security on that afterwards. Other things you can do from here, you can go in and add new lists. So I'm going to go and add a list for fun apps, because really aren't they all? So I've set that up, and right now I can actually determine which, from here, which applications are going to be found under Fun Apps. And I hit OK. We see we do some configuration. Well, I'm not doing it. VTScada is doing the configuration. And we can simply click over here to Fun Apps. So these are the ones I clicked. So if you've got somebody who works in a very specific part of the organization, you can set up a list for them. So one of the ways in which VTScada or all SCADA systems are being used now is in a data center or as part of a cloud system hosted in the cloud. So very often that means that VTScada is actually running as a service, which means there actually is no front end. There is no, on a desktop anywhere, there is no VAM to see. It's running as a service. It's running under the hood, and people simply connect to it as redundant servers or as thin client connections. So with VTScada in version 12, we've made that experience easier. You don't have to actually stop the application and then reopen it in standard desktop mode. You can actually access the VAM as a thin client, and it's a little bit complicated to show up, but suffice to say it looks a lot like this. In fact, it looks almost exactly like this. And so what it means is that you can remotely connect to an application running in the cloud, and you can do all of the same sort of system maintenance, configuration, start and stop applications, configure thin clients, and all of that. So it just makes it a more seamless experience for the next generation of modern SCADA systems.
Thanks for that, Chris. I don't think a lot of people realize all of the work that went into the back of the VAM in order to make that work for everything that was going on, but it was a complete rebuild, not just a modification of what was there. So next up, we're going to be talking to CCU, is that correct?
That's right. We're going to go to CCU, Custom Controls Unlimited, and they're going to tell us about basically a hosted application that they use in combination with drones so that they can actually map signal strength over uneven, rugged, and dangerous terrain when they're trying to set up large-scale telemetry SCADA systems.
Right, yeah, that's very cool. So let's go and see what Devin has to say.
So we're going to talk about one of the problems that we faced in our core business, where we do a lot of remote wireless RF based systems, and no matter how nice and expensive gold plated type SCADA system we build, if it's got poor communications, it's practically useless. So, and we've had a few bad experiences where cost would get away from us because we were not quite prepared on the front end to know how tall our poles needed to be, for example. And I'm sure any SCADA systems integrator out there that has run into that before. So our computer models are often missing the mark for us. It's a good start, but not getting us there. So we ultimately adopted a policy and said part of our quoting and part of our scope of services when RF is involved is always going to be doing a physical path study. And this unfortunately created a roadblock just from a cost perspective to getting some projects up and going. So there's traditional approaches and challenges that you can go through to do a physical path study. It involves a lot of equipment, boom trucks, portable towers. It's very, very labor intensive. You have to have a lot of manpower. There's also safety concerns that are often dealing with climbing and such. So we had to kind of come up with a more cost-effective, safer way of doing these physical path studies. That's where
the drones come in.
Yep, exactly right. So, yeah, we still start with computer models often, and you'll see these two. These are, one's called a heat map, and it kind of shows how the received signal strength indicators change as you get away from the towers. And then on the right-hand side there is, we pick 2 points, get a cross section in the earth, and we hope to make that red line line up without any obstruction.
So basically, you're using the drones to map out single strength to do what would be dangerous or inconvenient for a person to do.
Correct, and we still there's still the human element in it. Here's just an example of portable tower, something that is a cost that we hope to avoid in using these drones, but it's also often a piece of the project where that's set up at a certain location, and so it becomes a combination thereof. But ultimately, the goal is to get to a site, deploy the drone. You're up and down in 15 minutes, and you're on to the next site.
That's great.
So
we're about halfway through. We're actually going to show some of these videos. You've embedded some videos in this presentation, but I think we're going to show them at the end. Tell us a little bit more about how this works with using the drones.
Okay, so we have a licensed operator, and have a lot of rules to follow as far as being able to fly a drone commercially. But we essentially get there, we set the drone up, we have a radio, and we have a 4G cell modem on the drone as part of the payload, and then we suspend below the drone the antenna that matches whatever frequency on the licensed or private radio network. And then we're able to, we essentially raise that drone up to different elevation checkpoints, and we're getting feed down to our tablet from both the drone as well as our hosted SCADA system that we use to take the cell data, the 4G data goes back into our hosted system and is collecting all of this GPS coordinates, the elevations, the RSSI values, and it's recording it and mapping it to that location. And that's, we turn to the bearing that we need to, and that's how we do it. So this is part of the study will often involve putting temporary radios on top of towers. So this one is a little black box there. It's got a radio in it, battery powered, that'll sit there through the duration of us going around to all these sites to deploy this drone and get our data. So then this is a view of view that's optimized for the tablet that would have all these values on it. And those of you VTS users know that exclamation point there is our manual data. That's what happens when you wait too late to put your slide together. I had to cheat a little bit. So this stores all the notes and the heights and the signal strengths and gives us a live view while we're doing the test, and then saves all this data to ultimately generate the report we need.
That's great. So tell us a little bit about the hosted solution that you created. What were some of the, what's important when setting up a hosted solution?
Well, we have a hosted SCADA solution for our clients that has a secure private cellular network that tunnels back into our primary and redundant location sites. In this case, we used, and I'm unfortunately no longer the programmer here, but we used SNMP over UDP, and we connected to the all these acronyms for everyone, the GE's MIB to get all of that information out of that radio. And if you need some more acronyms, I can throw them out there.
How about WOW?
Yeah, that's excellent. I love that one. Yeah, so that's
you've also got the embedded mapping there too. So that's a nice thing. I guess that's an important thing if you're mapping drone.
It is. I mean, and ultimately we can, without the drone even, we can send our devices out sometimes and mail them to the customer and say, press this click. And it's and we know where it's at. We know what the values are. and we don't have to deploy people to do it. So a lot of values even outside of the drone to using this method of path study.
Now, that's really interesting. I think that sort of brings us down to the wire. So what advice would you give to somebody who was looking to adopt this technology? If, again, who's looking for this?
Well, originally it was systems integrators. It was us. We wanted to know this information before we got into the job and realized we made a mistake on the path analysis. But now we've determined that it's really valuable to consulting firms that want to know how to pre-engineer and pre-design what all of these heights have to be. And they realize the computer models themselves are not enough. So the physical study, they can hire us or someone like us to come out and do this physical path study.
Okay, that's great. Well, once again, thanks for joining us. If people would like to learn more about this company and about this technology, again, go down to the links in the description for this live stream. So again, thanks for joining us and have a great day.
Yep, thank you.
Well, that was great.
Yeah, I think although that's repeated content, that's probably the piece that's generated the most talking points and other things from everything that we've seen in the Automation Village so far. People are really intrigued at using drones for that application.
Everybody loves flying robots.
This is
Dave,
true.
Up next, you're going to actually show us an interesting, finer point of VTScada that not a lot of people know about, but can make a real difference to your day-to-day using of the software.
Right. This is something that I do a lot. For my own system, for my own computer, and it's something that you can run VTScada's Anywhere client and make it look a whole lot cleaner, or really do this on any websites. As I talked to in the video, this is something I use for YouTube, for Gmail, for all kinds of different things. So it's something that we thought you guys would be interested in, and something if you're a system integrator or an end user, it can really help with your presentation of your SCADA system or any website that you use. Okay, so in this segment, we're going to be looking at taking any website and turning it into an application on your computer. I'll show you quickly how that looks at first, and then I'll show you how to do it. So to start off, I'm going to hit the Windows key and just type in the name of one of my apps. In this case, I'm going to look at YouTube Music, and this is something that I use all the time because I don't like bringing YouTube Music up and having the URL, having everything else. It just looks dirty on my desktop. So I can bring up YouTube Music in a nice, clear fashion here. I could play something just by clicking it, and this actually also allows me to use the hotkeys and stuff on my computer to do play, pause, next track, whatever. So it's super cool. It looks way better than having the website up, and it's really easy to do. So I want to show you guys how to do that and then give you some ideas on where you might really use this. Let's look at how it's done. The other thing is you can see that I'm actually using this on my Gmail. I've got it docked down in the bottom here, and to dock it, it's just a matter of right clicking and saying pin to taskbar once you've got that running. So you can go, you can search them. I can also get to my Gmail right through here. So again, so how do we do this? So next up, let's take a look at the website SoundCloud, and let's do something similar to what I've done with YouTube. So we're going to grab this little mini burger menu up in the top corner here. I'm using Edge based on Chromium. It's the new Microsoft browser. I think it's a really good browser. If you're not using it, you should definitely give it a shot. Whether or not you're using any of the Chromium-based browsers or even Chrome itself, then it's kind of a similar method doing this. The menus might be slightly different, but it should be more or less the same. So we're going to jump down to the bottom here in the menu, and we're going to go down to Apps. And we're going to say install this site as an app. So you can see below all of the different sites that I have already installed here. So I'm going to click install this site as an app. It's given me a chance to put in a title, what I want the app to be called. SoundCloud's perfect. So I'm just going to click install. And now you see that we've got SoundCloud in a much nicer fashion here. And now the real reason that you might really want to do this is thinking about the VTScada thin clients. So you know, normally you go into the thin client in the Anywhere and you're inside the browser. You can always put that in a full screen, but it's something that you have to do every time. So now using the same method, we can take the VTScada thin client, bring it in just like an app. So I can go here to my water demo app, and it's a single click, and I can dock that into my taskbar. And here we go. So just sign in quickly, and here we go. Now that I've got this up, you can see I've lost the URL bar. I've lost all of the different buttons that might be kind of a pain. I've got a little back button and a refresh button, and I can still drop down the menu and stuff here if I want to. But yeah, just as you'd expect, it's the full anywhere, so we can go in and look at these things, do some trending. We can do our notes, whatever we wanted there. So if I want to grab the system notebook, click on here and say we want to add a note, and this is a test of the notes. Okay, and there it is. So pretty cool. Like I say, I think this is probably one of the cleanest ways that you can use the Anywhere and have that installed and really give your customers a great experience. Again, if you want to put this on the desktop, you can do that. You want to dock it down to the taskbar, you can do that. And if they want to get rid of it, then it's super, super easy. You can just grab the menu here if you want, just say uninstall, and we'll blow it away. So perfect. Hope you guys enjoyed this video, and now we'll bring things back to the studio.
That's great. That's particularly useful for users who are part of a hosted system where the only way that they access their application is through a thin client. It's just a nice way to get right to work.
Right, yeah, that's right, Chris. Being able to launch from your desktop and dock and other things really helps take that experience a little bit higher level than clicking and having to navigate inside the browser. So
right.
Thanks for that. And next up, we're going to be talking to Kevin Simpson at Xylem, who's going to be telling us about what he does for work, and that's using autonomous vehicles in site selection for SCADA measuring tools. And it's really about playing up the idea that quality data is really the most important thing, and it doesn't matter what you do after that, you need to start with quality data.
That's true. Let's have a look.
We're going to talk today again about the importance of selecting sites and how we can use survey vehicles to do that. So first, we'll start with the different types of survey vehicles. Then we'll move to the value proposition of using survey vehicles. And then we'll talk about some of the considerations around continuous monitoring and remote monitoring. And then lastly, we'll jump to some examples of both stormwater and source water monitoring. So when we look at the different types of vehicles, we'll start with sort of unmanned aerial vehicles. These are vehicles that are obviously airborne. They can look at imagery using things like LiDAR, cameras, and etc. to kind of get a big picture, sort of above surface view of the watershed. Next, as we get down towards the water, we can use what we call autonomous surface vehicles. These can also be both autonomously operated and remotely operated. I did want to mention one of the advantages of using vehicles above the water or on the surface of the water is that continuous data feed and being able to look at data as you're underway. And lastly, we use autonomous underwater vehicles. These are vehicles that are subsurface and allow the vehicle to basically undulate through the water column to collect three-dimensional data. And that's the advantage of using an underwater vehicle. So what are the primary vehicle functions? Both the surface water vehicle that I showed you and the underwater vehicle have the ability to collect water quality parameters as they're underway during a mission. They also have the ability to look at bathymetry data. That's basically the submerged terrain, but also being able to do volumetric calculations. This is very important in source water, whether you're looking at a drinking water reservoir or a hydrofracking pond or any water that's contained in a source water environment. Next is the hydrology component. This is where we look at water current, water velocity. We're able to profile that. As well as calculate discharge. This comes important in hydroelectric examples where we're looking at conduits and water. It's basically translated energy. So having that exact amount of water calculated is important. And then lastly, imaging type techniques using things like side scan sonar, multi-beam sonar, other things to look at exactly what's on the bottom and to get a better idea of what's subsurface. Yeah, so again, the premise behind the discussion, again, is the efficient characterization of watersheds. I can't emphasize this enough. Every watershed has its own personality, and it's actually extremely difficult to just guess at where to put a monitoring site. It's often done that way, but it's not always effective. So again, the advantages of these vehicles is the ability to look at large spatial data sets. And in those data sets, again, we can look at things like bathymetry, water quality, hydrology, and water analysis, all during a single mission. Another really important thing in all watershed and surface water environments is identifying point source and non-point source contributions. A point source would be like a thermal discharge from a nuclear plant, an effluent discharge from a municipality or a wastewater treatment plant. And non-point source would be, leaking septic tanks, agricultural runoff, things that are more difficult to pinpoint. But all of this, it's basically optimizing the ability to deploy a continuous remote monitoring system and get that actionable information. So this is a tributary off a lake. This is a very common application where we set up a mission by putting these waypoints within the watershed that we want to characterize. This particular vehicle was used, or actually the vehicle that we used was an autonomous underwater vehicle. And as you can see, it's quite a intricate pattern here covering a large spatial area. This particular mission took 4 hours and 43 minutes, but my guess is the technician enjoyed a ham sandwich and a bottle of Gatorade, did some other work during this mission. So another advantage of an autonomous vehicle is obviously unmanned and a lot less risk of putting people out on the water. So my guess is at this point in the presentation, everyone's wondering, what does this have to do with SCADA? So, this exact example right here, we're looking at dissolved oxygen, and this is basically a geospatial overlay of that data in this particular tributary. But this example was actually used to where to locate some temperature monitoring stations from a nuclear power plant effluent cooling water. But it could also be applied to perimeter monitoring for different industries, for stormwater runoff. It could be applied for hydroelectric on where to monitor both water quality, influent and effluent. All that is typically tied to a SCADA system, whether it's an operational decision-making tool or whether it's a historian type compliance. It's very common that we connect these remote outdoor monitoring stations to SCADA. Dissolved oxygen is one of the key water quality indicators, and you can see the dynamic nature of how this is distributed in this one little tributary. And I just want to show you, kind of an example of a hot spot. If you look in the bottom left corner, there's a small little red, orange, yellow site there. That's actually where we have high dissolved oxygen. That's not such a bad thing, but what happens is during the diurnal process is that might drop to extremely low during the nighttime and have things cause like algal blooms, etc. But this was likely caused, and I'm guessing here because this is I didn't do this particular survey, but this is probably due to some non-point source runoff, like nutrients, fertilizer, etc. But you can see how difficult it would be to place a monitoring site without having this information or any baseline information. You would literally be guessing. So again, I just want to emphasize that point. So some of the considerations when looking at doing continuous monitoring or setting up a continuous monitoring site is ultimately your monitoring goal. Is it a compliance? Is it a baseline project? Is it an operational type project? Is it a mitigation? Is it remediation? But identifying your goal is obviously paramount before we move to, what equipment we're going to put on the site and where that site should be. So again, I've already kind of jumped to that, but the next example would be, what equipment do I need? Do I need level sensors, water quality sensors, water velocity, precipitation, weather? This is where in that consideration we choose that equipment based on our monitoring goals. Next is really around the instrument preparation. This is where we configure the instrument, set up the sensor to report data or the instrument to collect data. Next is actually deploying the sensor properly, where we put it in the water column, make sure we reference it to an elevation or stage, et cetera, et cetera. And next, and this is where, again, ties into SCADA, is what type of telemetry do we want to use? Do we want to deliver the data cellularly back to an HMI software database, or do we need to remotely transmit it Modbus to an RTU, as an example? So this is where we make that decision. Field maintenance is probably also one of the most important aspects. How often do we need to maintain the site, check on the battery, clean the solar panel, etc. And then when we get down to the sensor level, the in situ type monitoring equipment, we need to look at, what happens to the equipment after we bring the sensors back. How often do we need to calibrate the sensors? How often do we need to perform maintenance? This can easily be done after that first deployment and then fine-tuned. So these are the considerations around monitoring, setting up a monitoring site. I guess, if we look at stormwater monitoring, this would be a good example of where we would put level sensors like bubblers, non-contact radar level sensors that are referenced again to an elevation or a reference point benchmark. Water quality sensors where we do things like temperature, pH, dissolved oxygen, turbidity, chlorophyll, etc. We can look at things like water currents and water volume in open channels using acoustic Doppler profilers. That's on the bottom right-hand side there. And then we can look at meteorological parameters like precipitation, which is obviously key to stormwater. And we can do adaptive sampling using that data logger as a control system. So during a storm event or after a storm event, we can step up specific types of measurements. So this is kind of holistic view of a stormwater monitoring site. And again, it can often be times connected to a SCADA system. Yep. Now we're going to jump to source water monitoring. This is where we look at basically the reservoir. And this is an operational example of looking at water quality and which intake to use. So if you look at the left-hand side here, we have a floating platform that's raising and lowering a water quality sensor through the column. And again, this is oftentimes tied to a SCADA system so that there can be operational decisions about using the upper intake, the mid intake, the lower intake. And on the right-hand side, we have a permanent one. So source water is very commonly interfaced with SCADA at the beginning of the drinking water treatment process. So just a quick little breakdown of what entails a source water or even a stormwater site. Again, we're going to break it down on the sensor level: rain, weather, things like photosynthetic active radiation. I can't even pronounce it. Goodness gracious. But this is basically the amount of sunlight. This is really key to looking at things like algae and algae proliferation and being able to mitigate algal bloom problems. Again, oftentimes tied to SCADA. And then water quality. And again, below, we see some examples of how we interface with SCADA. So that kind of wraps up the source water part, Chris. Greatly appreciate again the invite. Hope this was informative.
Thanks, Kevin. What's really great about that is that you can literally just throw a bunch of robots in the river and they can help design your SCADA system.
Yeah, that's right. Kevin alluded to the fact that, it's a great time for the guys to have lunch or whatever. Now, I'm sure there's a lot of preparation and a lot of work leading up to
Right.
that, and then a lot of analysis to be done afterward. But while the robots are doing their robot stuff, is just about ideal in the nicest part of the day.
On that note, it is time for our final prize giveaway.
Contest time, yes. So what you're seeing on the screen right now is going to be the email, natasha.lutz@trihedral.com. So send an email to that address with the subject line, Chris.
Integrated SCADA features.
Integrated SCADA features. So, and all caps, just as you see it, send that right away and you'll have a chance to win. So with that, I hope you guys are $100 richer, and that also brings us to the end of our show today. So first off, we want to make sure that we thank everybody involved in the show, and also thank you guys for joining us today. Big thanks to our presenters, because without them, we wouldn't have a whole lot of content. You'd be watching Chris and I click around in VTScada for an hour, so it's nice to break that up and have all kinds of other things that we can bring you to sort of keep it a nice, well-rounded show.
So before we finish, as many of you know, the Automation Village is brought to you by VTScada by Trihedral. And during our trade shows, Dave and I will often tell you about various features of our software. If you'd like to try it for yourself, you can do that for free by downloading VTScada Lite, which is the free perpetual industrial license for applications up to 50 I/O. It comes with one thin client, and you can download that now and start using all of our pre-made videos and tutorials. Also, take a second right now, and click on the little bell and subscribe to our channel. That makes a big difference to us. Like this live stream. If you have any questions, type them in now. We'd be happy to respond to you. And finally, we hope that you'll join us next month for the August edition of our Virtual Trade Show Summer Hours.
Right, and that's going to be a similar format to this, where will be a shorter show, roughly 1 hour in length, and then come the fall, we'll probably go back to our normal format where we bring you quite a bit more content over a little bit longer show. So thanks everybody for joining us today. We hope you have a great day.
Bye now.
Goodbye.